Hey.
Hi, how are you?
All right.
Oh.
Hello.
Good
Morning.
So we have
Morning.
Good morning, our time.
Norwegian Institute
Yeah.
of Science.
Good evening.
Yes.
Yeah. Okay. Ed, I'll tell you what, why don't you start us off there if you have a question there.
Okay, I gotta double check to make sure I got which team here. Whoops. Oh,
This
shoot.
is Team 61,
Yes.
the Norwegian Institute of Science Technology. Yeah.
Yes, the people that I want to visit their country.
Right.
This one's actually for, is she on here? Cecilia?
Yeah, she's not here, but we can answer for her.
Okay. During her talk about the main chute opening up, and it's actually, she was indicating that the rocket velocity as it descended was increasing. So I was a little curious what type of parachute. Okay, I'm going to be facetious here. What type of parachute increases acceleration as it descends?
I'm guessing that's a slip up. Do you wanna
Yeah,
say something on that, Vebjørn?
yeah.
Yeah.
Yeah, I think it was a slip up, but she was, I think
Yeah,
she
it's,
meant to say
yeah.
de-accelerate rather than
Okay.
accelerate. So
Yeah,
was
yeah,
a
I'm
little-
guessing you meant that. Because due to the density of the air, the velocity will slow down when it
Yes.
comes lower. Yeah.
right.
So
Okay.
that was a mistake.
Yeah, that's even at terminal velocity. It's going to slow down because of the increasing air density.
Right. I mean, you open up the bigger parachute, it's got to slow down. At least I certainly hope so. Otherwise, it's
Yeah, there's going to be a
really
high load from
spectacular.
the, yeah.
And that was the only question I had for you guys. I really enjoyed your presentation.
Thank you very much.
Great.
Oh, thank you.
Any questions?
I'm
Yeah.
Report?
I was
Yeah, sure.
yeah, I was interested in your the way you did your boat tail. I thought when you used the mandrel to make your nose cone, and then you decided to turn around and use that for your boat tail, which struck me as that's a pretty interesting way to go. But as far as the actual shape of that boat tail, did you do any simulation to see if you would have better better characteristics with a different shape? In other words, you had this second thing, and so you used it, which I thought was great. But did you consider whether or not that was actually the best way to go versus
That's a good question.
the easiest way to go?
I think mainly it's the easiest way to go for us there. However, we did actually compare using just a straight fuselage and with the boat tail, and using a curved boat tail with the von Karman shape, and that showed that it have a little bit lower drag. I don't think actually that this is very critical. Yeah. We could easily have flown the rocket without the curved shape boat tail, but it made some of the manufacturing a little bit easier because we could sort of fasten the aft end of the fuselage directly to the motor, sort of, without too much sort of aluminium in between, and it made our boat tail smaller, which is a machine part, and so that's maybe the main reasoning behind it. But it did actually show a little bit decrease in drag.
Okay. Joe, over to you. You at the
Yeah, I'm curious about your chute release. That the tender descender style has been very popular, and this year we started asking more seriously, does the tender descender provide any kind of redundancy? And the answer we've been coming up with has been no. And so I'm going to ask you, first make sure I didn't misunderstand. Does your chute release have any redundancy in it?
So up to, I'll let you take it.
Yeah, thank you. Our main chute release system has redundancy on the form that we have two separate servo motors that can activate the release arms that are connected to each independent flight computer, which again is connected to an independent power source. But however, there's only one release arm, so the redundancy kind of stops there. And as of the tender descender, I believe it uses black powder, right, to release, which is prohibited here in Norway, which is why we don't have used that though.
Yeah, okay. I missed that you had the two servos working the release arm, and so I would call that redundant enough.
Yeah. Nice.
So we
Thank
did
you.
consider like the possibility that something might jam in the mechanism, but it is quite protected. Sort of the release arm lies between the shells, and only a small part of it sticks out. And so we deemed that the risk of this was very low, and therefore acceptable with redundancy only up to the actuation.
Thank you.
Okay. I don't have a question at this point, more than your I thought your overall project was very good and very well put together. But the one thing that I ended up having to search around quite a bit and actually ask for my fellow judges, for, is that you didn't have a explicit weights and measures section in your appendix in your technical report. And, instead, you had the data was out there, but it was scattered in different places. And that was one of the things that prompted my comment at the discussion yesterday, was that, don't make the judges guess about whether something is there or not. So if we say we want to see an appendix that says weights and measures, then you need to do that pretty unambiguously, because that if I hadn't gone through the extra effort of searching it out and asking my fellow judges what they thought, you would have lost significant points on that deal. So, just as an advice for next time, be sure to follow the directions to the letter. Don't make us guess whether or not you got it there, because most people will, if they don't see it, they're going to say, well, it's not here.
Well, at page 180, there is a weights and positioning of components list, which has the weights of every component and their position or in relation to the nose tip.
Right. Yeah. I mean,
is this the kind of thing you're looking for?
It looked like you
So
were
it's more
missing
like the
title, the title page for that says,
right.
Here's the weights and balances and everything followed. It was like that page just wasn't there. Everything else was labeled, but not that one. So
really, okay. There's a title page here in my documents saying weights and positioning for CG calculations. Maybe that's a bit ambiguous title, or?
Yeah, I mean, it should have been in the very first appendix after your conclusions.
Okay.
Not
buried
down in something else. So, yeah. So, like I said, make it, unambiguous. We've got a lot of papers to look at, a lot of schools to score. So, don't. A lot of people are just going to say, okay, I didn't see it. It's not there. Points taken away.
That's some great feedback.
Great.
Yeah.
Nice feedback. Thank you.
Yeah.
Yeah.
yeah, I'm a college professor in my other life. So so it's not an uncommon error. All right. Ed, you got another question?
So I would like to make another comment on that, which first off,
Okay, sure.
dog training, never make the judges think. But while the labeling left a bit to be desired, yeah, the most complete and exhaustive and possibly exhausting description once it was found. That really is outstanding, and that should be mentioned also.
Thank you.
Yeah, no, it was, yeah, there was a lot to like about your project there. I thought it was extremely good. Okay. Ed, you got a observation or comment?
Yeah, I thought let's see if I got the right nomenclature, because my brain is mush looking at all the stuff. The MCRS, is that right?
Yeah,
I thought that was a really innovative way to take care of the problem, and I liked your description in the technical report of the problem you ran into of it jamming, and then coming up with a solution. So that was, I thought that was a really nice highlight on your project. And I see
we do have that on the podium session as well, which we're grateful for.
Yeah, so I see Johan's smiling there. Is that how you pronounce it? Yeah. Johan? Okay. I don't speak Norwegian.
Yeah, it's quite hard to pronounce. It's quite, yeah, quite close.
Okay.
Did you get a chance to look at the simulation appendix?
The one with all the code there?
One? That's the CFD.
Yeah,
like
I mean, we looked at it. I didn't. Yeah, I personally thought that was probably too much detail as far as that, as I recall from the report. But I'm not going to mark you down for. We're not going to mark you down for too much. So that's but that would be the kind of thing, like when I did my doctoral dissertation, I wrote a simulation model and all the code, and I put all the code in my dissertation. That's the place where you'd expect to see that kind of detail. So, good on you for being able to do that. Okay. Anything else, gentlemen, ladies? You got a quick question for us?
Yeah,
right.
I guess.
Well, you are released. We are looking forward to seeing your podium there. Go ahead, Oscar.
Oh yeah, I was just wondering what you thought about the OpenRocket as a simulation tool. How good it was.
I mean, that's the one I use all the time. But I'm not, shooting to 30,000 feet or anything like that. It's got its limitations, especially in the supersonic realm. But as long as you use the tool within its limitations, it's perfectly good. Joe or Ed, you got we weigh in on a quick opinion on that?
No, because I use RocketSim.
Yeah, I'm actually one of the OpenRocket maintainers, and I would comment that we are doing what we can within the limits of the data we've got. And something I would love to see would be more launch data coming back to us so we can better validate our models.
Yeah, I don't have an opinion because I use RocketSim.
Well, that's good. Yeah,
Go ahead.
All right. Well, our time is up. Y'all are released. We're looking forward to your podium session. And thank you very much for an excellent job.
Thank you very much.
Thank you.
Have a nice day.
Have a nice day.